Over word problems, real world applications. These tend to be harder. The math that you do, like the actual computations that you do, is stuff that we've done this unit. The problem is I don't just give you the equation. You have to come up with that from the real world, like the explanation from that situation, which is usually harder. So I have picked out specific types of examples that all follow the same sort of pattern. And that'll help you a little bit because you kind of know what to look for. That'll help you come up with the equation. But you still have to be able to read and understand what's happening in this situation and what the question is asking. So most of these follow a linear function. You learned about lines in Algebra 1. You learned y equals mx plus b. You learned that in Algebra 1. All of these are going to kind of follow that pattern. Okay. But we're not going to use y. We're going to use f of x. And actually in word problems, I don't always use f and x. I might use C and some other letter. You pick letters that make sense for your problem. So if I'm talking about the cost, a lot of these problems have to do with money. I might use C for cost. Okay? And we pick out letters that fit our variables. All right. Now, usually there is some kind of starting number. Maybe it's like an initial fee, or just like a base number, just some number that doesn't change. It's a flat rate, flat number that's set. So you usually will have that number, and then you'll add a number with your variable. Meaning whatever this number is, it gets multiplied by the variable. Some special words to look out for to give you a hint that that number goes in that blank. You might look for the word per. Okay, like it's, if you make $5 per hour, you multiply 5 by the number of hours. So we're going to be multiplying something by a variable. If you have a percentage, that will always be multiplied by a variable. So if you see a percentage, you don't just, if you have a percent, it's a percent of something. You have to multiply by the percent. If something is 20% off, you don't just subtract 20. Okay, you subtract 20% of that number. Okay. So let's get into some real examples. Owen paid a landscaping company $108 for an initial lawn treatment, then $74 per month thereafter. So what's going on here is somebody probably lives in a steady climate. It's warm. He needs some kind of landscaping done. He doesn't want to do it himself. So he's got a company that comes out every month, and they do his yard work for him. Now, like a lot of places, when you set up utilities, when you move out of your house, and you have to start a new electric bill or whatever, they always have some kind of like extra money you have to pay up at the beginning. It's not a per month, but y'all just keep in mind when you get your own place, you're going to have lots of little fees that come along. So that's what happens here. It's $108 for the very first time, and then it adds $74 per month, which means we're multiplying 74 by the number of months. Okay. So the first thing we're going to do is come up with our own function. Now we're talking about a cost, and that cost depends upon the number of months. So the more months I have, the more money it costs. So I'm going to use the function C of M. This whole thing right here just means the cost. That whole section. That's just the cost. The reason the M is there is it's telling me my cost depends on the number of months. Okay. And that's equal to, was there any of these starting number, flat fee, the initial fee, yep, of what? 108. Plus some number per month. What's that number per month? 74. So it's 74, and I'm using M. So 74 times M. And that's my equation, my function. So number 2 says to find C of 24. When you have a number in parentheses like this, we did these problems at the beginning of the unit. What did we do with those numbers? Normally we put it where the X is, because we did F of X. So I'm probably going to put it where the, if it's in parentheses, it's the M. We're going to put it in for M. So C of 24, that means that my M is 24. So C of 24 equals 108 plus 74 times 24. So you can type that into your calculator. Just type in after the equal sign. Brooklyn, did you type it in?
Yeah.
What'd you get?
1884.
So 1884. Do you all agree?
Yeah.
Good. So what does 1884 even represent in the context of this problem? What does this even mean?
How much it costs us for a year?
How much it costs?
For 2 years.
It's actually 2 years. So 24, remember that's a number of M. M is your months. So we did 24 months. So this is the cost. So he paid $1884 in 24 months. Yep. Number 3, how long has Owen been receiving lawn service if he is paid $18? Months. So this number we're going to put, so we're going to do 2994 equals. So we're going to set the equation equal to that. Do not plug that number in for M. If you plug a number in for M, you are saying that's the number of months. So it's 108 plus 74 M. So this is one of those where we have to solve the equation. All right. Michael Todd, what step do you think I should do first to solve this equation? Try to get M by itself. So minus 108. So the number that's by itself, you always add or subtract that first. So type that into your calculator. Micah, what did you get?
2,810.
2,800 and what?
10. Oh, wait, no. I put the wrong number.
2,886. Okay. Yeah, that's okay. Equals 74M. Dalton, what's my next step? To get M by itself. Divide. Divide both sides by 74. And Victoria, what do we get? 39. So 39 months, which is a little over 3 years. How many months would be in 3 years? 36. 12 times 3. 36. Good. Next one. Hannah's electricity company charges 12 cents per kilowatt hour plus a basic connection charge of $17. And she's going to see that on every bill. And so we're going to come up with an equation or a function to represent her monthly bill. How much is she going to pay? So we're looking at a cost. What would my variable be? What does my cost depend upon? In my last example, it was the number of months. The number of months affected my cost. What's going to affect your cost on this problem? The number of what? The number of kilowatt hours. The amount of electricity that you use, which is measured in kilowatt hours. So the cost is based on the number of kilowatt hours. All that means is this function that we find is going to give us the cost. All right, was there any kind of starting amount? $17, yep. So every month, even if her electricity was shut off and she used 0, she would still have to pay $17 to keep the company before they dropped her. Okay. She still has a meter. People from the company go out and read the meters. I guess maybe it's digital now. I don't know. All right, so $17 plus something per kilowatt hour. So how much is she paying per kilowatt hour? 12 cents. So 0.12. Okay. So you take 12 cents and you multiply that by the number of kilowatt hours. So the more electricity she uses, the more kilowatt hours, the more it's going to cost. Last month, Hannah used 995 kilowatt hours, and we're finding the cost of her bill. So where does the 995 go? Okay, it's 995 kilowatt hours. We use K to help you be like, okay, kilowatt hours. So 995 is your K. So we're going to find the cost for 995 kilowatt hours. So 17 plus 0.12 times 995. Just type that in your calculator. All right. Isaac, did you type that in? Oh, come get it. What number are you? All right, I'll come back to you. JC.
11.4 for 0.12 times 995 and then add 17 for 28.4.
It should be more than that. Do 0.12 times 995 again. 995. And then add 17 to that. What'd you get?
136.
Yep. $136.40. Which is about, I don't know, that's about what my electricity bill is in the summer. In the winter, when you have to use your heat, guess what? Goes up.
Miss Johnson, did you put the 0 at the end as like a placeholder or something?
When you're talking about money,
Okay.
money always it has 2 decimal places, yeah. If you just put 136.4, it's not wrong. Now number 6 tells us the amount of the bill. It's asking us for the number of kilowatt hours. So it's telling us that she paid $117.44. So where do I put that number? In the front or in for K? In the front. If I put it in for K, that would mean that that was a number of kilowatt hours. It's not. It's amount of money. So the cost, remember we put up here, the cost, that's in the front. So if it gives us a cost or gives us a dollar amount, that's in the front. Left my pens. So 117.44 equals 17 plus 0.12K. This is a whole new question. That $9.95 from the last question does not apply here. This is a different month. Now, based on this amount, do you think that my number will be smaller or bigger than $9.95? Smaller, right? She's paying less, so she should have used less electricity that month. Alright, so I'm going to solve this equation. Alright, Lacey, what is my first step? Subtract 17. Good. Alright, so you're going to do this 117.44 and subtract 17 from that.
And then do you divide?
We will, yeah, when we get there. All right, Isaac, now you can type that in and tell me what you get. So the 117.44 minus 17. Yep. 100.44 equals 0.12K. Good. And then, Kaylee, what do I do to get K by itself? Divide by, careful, 0.12, yep. So, go ahead and divide both sides by 0.12. And Alex, tell me what you got. 837 equals K. Which seems reasonable. It's kind of close. I mean, it's not too far from 995. The bills were somewhat similar. If I had gotten like 7 equals K, that would have been a red flag. All right. Alright, Jeff works at a car lot and makes commission on what he sells. What that means is that the more you sell, the more you make. So he doesn't make an hourly wage at this job. He has to work for his money. For each vehicle sold, he makes $60 plus 1% of the purchase price. And we're going to come up with a function that tells us his commission. Okay? So his commission, I'm going to use a C again, C for commission. What is his commission based on? What causes his to go up?
Car.
What about the car?
The price.
The price of the car, the purchase price. So I'm going to use P. P for purchase price. You don't want to use the same letter. Okay, so C, the commission. So what this is, all of this right here gives us his commission. That's equal to, what about a flat fee? For every matter, it could be the cheapest car on the lot or the most expensive car on the lot. But he does get rewarded a little bit for selling a more expensive car. That's where the percentage comes in. Do what? 1%. I'm going to multiply the purchase price by 1%. The problem is you don't have a percent button on your calculator. So to convert from a percent to a decimal, few ways to do it, but just take your percent divided by 100. So if I take, it's 1%, so 1 divided by 100 is 0.01. So we're going to multiply the purchase price by 0.01. So it's 60 plus 0.01p. So your regular all the time $60 plus 0.01 is the same thing as 1%. If you put 0.1, that's actually 10%. So be careful, it's 0.01. Okay. Number 8. If Jeff sold one car yesterday and he made $188.60 from that car, what was the purchase price of the vehicle? So that $188.60 that I give you, does that go in my front for commission or does that go over here for purchase price? What? $188.60. Which does that make more sense to be? It's the commission. You're not going to go buy a car for $188.60. If you do, you probably are not getting anywhere in that car. But it tells us that Jeff made $188.60, which is his commission. It doesn't give us the purchase price. It actually asks us for the purchase price. So it gives us the commission. So this one's backwards. Normally we were doing that type of question second. You got to read. So 188.60 equals 60 plus 0.01p. And we're going to solve that for p. We have to get p by itself. So Chantel, what is my first step? Subtract, not 0.01, we subtract the number that's by itself, 60. So you subtract the number that's by itself, which is 60.
That gave you 128.6.
Yes. Good. And then Emily, is today your birthday? Happy birthday. What do you do next? Divide by 0.01. And Dale, what do you get? 12,860. That's how much the car costs. Because remember, it equals P. P is the purchase price. So 12,860 equals the purchase price. Not bad. Now, Robin is going to this car lot. She's going car shopping. She buys an SUV for $17,450. We want to know how much commission Jeff makes on this. Is it going to be more than $188 or less? More. A more expensive car means more commission. So you should get a number a little bit over $188. So $17,450. Do I put that in the front for commission, or do I put that in for P, the purchase price? P for purchase price. $17,000. She buys an SUV for $17,000. So that's your purchase price. So it's 60 plus 0.01. So type that into your calculator. And Katie, what do you get? Yep. $234.50. I know. Too bad it was not 56 cents. Then I would have been. I'm the type that I like to look at my odometer, and when it has like a cool pattern of numbers, I get excited and snap a picture to somebody.
Look at your what?
I typed in an exact.
My odometer, is that what it's called? That tells you how many miles are on your car? Is that what it's called? Yeah. You got what?
I never had the decimal. Oops.
Okay.
Sorry.
You're good. All right. Next example. The cost of a large cheese pizza is $7.25. Each additional topping is 65 cents. So it's 65 cents per topping that you get on there. So you assume everybody gets the base cheese pizza, and then you add toppings on that. So we're going to write a function. So I would probably use C for cost. What is the cost depending on? Your toppings, right? The more toppings you get, the more it costs. So I'm going to use T. Now be careful, because sometimes the T can look like a plus sign. Right. So maybe you might want to make that a capital T. So I want you to write what you think this function is going to look like. Riley, you want to tell me what you got?
I got $7.25 plus 65 cents.
How do I write 65 cents?
0.65.
Do you have to put a 0?
No.
And you put the T.
Good. Right, because you would take the 65 cents times your number of toppings and add that on to the base $7.25. Alright, so Liz orders a pizza and adds sausage, bacon, banana peppers, onions, and mushrooms. Gross.
That's going to be it.
Now, I like bacon and banana peppers. That's my favorite. Bacon and banana peppers. But not all that extra stuff. Well, mushrooms are disgusting. Alright, how much does her pizza cost? So it's giving us the toppings. How many toppings is that?
There's 5.
5. Yeah, I didn't actually explicitly list the number 5, but if you count up the toppings, there's 5. So 5 toppings. Do I put that 5 in the front for cost or in for T?
T.
T. 5 is a number of toppings, T. So we have 725 plus 0.65 times 5. Make sure you put the 0.65, otherwise it's going to be a difference.
That would be $332.25 for just that one pizza if you don't have it.
Yeah. What? Pizza Hut is my preferred pizza.
All this be plus taxes.
you would take that times 1.06. Would give you the total cost.
You got a family ants back here.
Do I really?
What
Oh yeah, most of these classes down this way.
Plus what? 20.
Okay, I'll call janitor.
It's gonna be me and the-
All right, Shayla, did you type it in the calculator? What'd you get? Yep, $10.50. Good. All right,
Plus taxes.
I'll get a janitor. Hold on.
Plus
If Sam has to pay $13.10 for his pizza, how many toppings did he get? So, where do I put the $13.10? In the front or in for T? In the front. It's a cost. So $13.10 equals 7.25. Sorry, plus 0.65 T. And I want you to solve that equation. All right, so this one, Michael McKinney, what was my first step in solving this? No idea.
Do the equation. Yeah. Oh, I don't know.
So my goal is to get T by itself. What was my first step in this problem? Yes, you're going to subtract the number that's by itself. And Callie, what do I get when I subtract 725? 5 what? 585 equals 0.65 T. All right, and Dale, what's my next step? Yep. Divide by 0.65. And Emily, what do I get when I divide by 0.65? Okay. 9.
You went in there and asked for all the toppings.
That's a lot of toppings. Good. All right, we have one more, and this one's a little bit harder. Okay, I'm going to walk you through this one. A lake near the Arctic Ocean is covered by a 2 meter thick sheet of ice during the cold winter months. As temperature rises, the ice begins to melt. 0.1 meters per week. All right, we are calculating the thickness of the ice. So we could use T for thickness. You could use an I for the ice, whatever. And that thickness is going to go down per week. So it's the thickness is based on the number of weeks. The more weeks it's been, the less thick my ice is. So where's a starting point? Where does my ice start at? 2 meters, so just 2. Then what happens to the ice? It melts. And when something melts, when the ice melts away, what happens to its thickness? It gets smaller. So every other time I've added. But if I want it to get smaller, Micah said we need to subtract. That one's a tricky one. We subtract, and it's 0.1 or 0.1 per week. Yeah. So number 14 says, how thick is the ice after 7 weeks? So it's giving us a number of weeks. So you plug in 7 for the W. The front is the thickness. Okay, so it's asking us for the thickness. It gives us the weeks. So we have 2 minus 0.1 times 7. That would be if you plussed. Right. Victoria, do you have it? Yep, 1.3 meters. Number 15 says, how long will it take for the ice to be completely melted? I gave you no numbers right here. But you can come up with what number. You have to plug in a number somewhere. Plug in 0 where?
For the thickness.
Yeah, if it was completely melted, the thickness would be 0. So we're going to put a 0 in the front. We're going to solve that for W. So, first thing we're going to do is subtract the number that's by itself. So we're going to subtract 2. 0 minus 2 is negative 2 equals negative 0.1 W. And then you divide by negative 0.1. And Dalton, what do you get? 20. So 20 weeks for the ice to be completely gone.